हेलो माय डियर मैकेनिकल चैंपियंस, हाउ आर यू ऑल? व्हाट्सअप, कैसे हैं सब लोग? प्लीज गाइस डू जॉइन मी फास्ट फॉर दिस वंडरफुल फॉर्मूला मेमोरी टेस्ट सेशन फॉर द सब्जेक्ट ऑफ हीट ट्रांसफर. So please do join me fast, and those who are already here, do respond me through the comment section if my audio and visual quality are fine. Hi Anirudh, welcome. Good evening guys, please settle down fast. So this session is all about revision of your formula. But how we are going to do the revision of all the formula from the heat transfer? I will give you some questions related to the formula. There will be no numerical, there will be no conceptual question. The question will be related to the formula only. For an example, I will ask you what will be the correct expression for radiation shape factor, and the four options will contain the different expressions. So in this manner you will be able to recall your formula which you have studied previously, which you have revised previously, for which you have already done the numericals. So in this way you will be able to get an idea whether you will be able to recall the formula or not. Namaskar, Adab, Shubh Sandhya, good evening, Sat Sri Akal, Assalamu Alaikum, Vanakkam. Please get yourself settled down fast, sit back, relax and enjoy this beautiful session. So let me quickly introduce myself. I want everyone to keep responding like Anirudh is responding, because the more you respond, the more you give me the answer for the formula, the more understanding you will get whether you are in a position to recall those formula or not. All right. So just let me give you an introduction, quick introduction about myself. I am mechanical engineering graduate from IIT Delhi. I have also cleared engineering services examination, and I have worked in Steel Authority of India Limited for more than 2 years, as well as I have worked in a private consulting firm for more than 2 years. So my total industry experience is more than 4 years, and the rest of my experience is completely into teaching. I have been guiding the students from last 11 years for the various competitive examinations. And I am quite comfortable in these many subjects of mechanical engineering, fluid mechanics, thermal, heat transfer, as well as industrial engineering. So if you have anything to discuss, any doubt you want to have a discussion about, you can always connect with me through my official mail ID, that is chandra.shekhar7@byju's.com, or you can join me on the Telegram. That is important. Once you become part of my Telegram channel is Mechanical by Chandrasekhar. The link is also mentioned at the bottom. So there are already more than 1500 students who are part of my Telegram channel. When you join such a group where all are GATE aspirants, it will help you to improve your preparation. It will help you to give you the motivation to work harder and get success in your examination. So once you join me on the Telegram channel, we will be providing you the notification of the various examination. The PDF of this session will also be provided to you through my Telegram channel only. Study notes, updates about various important sessions, and doubt clarification and the important question practice will also be shared through the Telegram. Hi Kumar, good evening, welcome. How are you? So how is your weekend going on? Are you all ready? Did you guys appear for the mega mock test which got completed yesterday, 3rd of November? Second mock test for Subjectwise. Third mock test is going to be started from 11th of November till 17th of November. And the syllabus of the next Subjectwise mock test will be manufacturing, engineering materials, industrial engineering, and IC engine. The pattern will be same as that of your actual GATE pattern, right? So do not forget to appear in all the mock tests. There are 4 subject-wise tests and 4 the full length test. Once you are able to complete all these tests, believe me, your confidence will be at the next level. After the appearing for the mock test, after the result, do analyze your performance also. Whether in which areas you have committed the mistakes, what are your weak areas, what are your strengths. Accordingly, you can plan your strategy for the remaining final days of your GATE examination. All right. The link to register yourself for this mock test is already there in the description box. And one more important thing, based on your performance in the scholarship test, you can get or you can unlock our test series. Yes, the test series which is designed by our team of experts for the GATE 2024 examination. You will be able to unlock the test series at a very highly discounted prices, very cheap prices. You are able to get the test series. So your performance really matters in these mock tests to get our test series. All right. So please keep your pen and notebook, sit back, relax and enjoy the beauty of this session, and do let me know how many formula. There are around 20 to 21 questions in total. So we will discuss all these questions. They are direct formula based, straightforward questions. So we will try to complete these 20 to 21 questions in the next 35 to 40 minutes. All right. Are you all ready? Everybody, please do mark your presence. Before I start the session, do mark your presence by writing in the comment section. Yes, Saurabh, Anirudh, Kumar, well done guys. And I welcome you all once again from the bottom of my heart to this wonderful session. Some question will be from conduction first, then convection, then radiation and the heat exchanger as well. And let me tell you, I have included some MSQs also in this session. So let us start with question number 1. Everybody, please do give me the answer for question number 1, which is from the basics of heat transfer. The formula for the convective heat transfer coefficient. The unit of H will be watt per meter square Kelvin, or we can write it as watt per meter square degree Celsius. What is the correct formula? Every one of you, please do let me know. So this expression we are obtaining from the no slip region. In the fluid of no slip region, the mode of heat transfer is conduction. In the no slip region of the fluid, the mode of heat transfer will be conduction, and outside the mode of heat transfer is convection. So the rate of heat transfer due to conduction as well as convection remains constant. So we can say Q is equal to minus thermal conductivity of the fluid. We can apply the Fourier law in the no slip region. No slip region is Y is equal to 0 minus thermal conductivity of the fluid into area normal to the direction of conduction into dt by dy. In case of Fourier law, we use the temperature gradient at Y is equal to 0 in the fluid. dt by dy in the fluid at Y is equal to 0, because we are applying the Fourier law in the no slip region of the fluid, is equal to the convection in the outer fluid, H into area available for convection into delta T. Delta T is called as bulk temperature difference, is equal to constant. So can you develop the expression? Can you find out the expression for H? So H will be equal to minus Kf into dt by dy in the fluid at Y is equal to 0 upon delta T. Delta T is equal to Ts minus T infinity or T infinity minus Ts. And how to get this delta T? So yes, definitely the correct answer. Yes, Anirudh, Kumar, well done. I want everyone to keep responding. Even if you are committing mistake, no problem at all. At least you will realize your mistake and you will not forget the concept, forget the formula again. B will be the correct answer. dt by dy is in the fluid at Y is equal to 0. Delta T is the bulk temperature difference, that is surface temperature minus fluid temperature or fluid temperature minus surface temperature. How to get dt by dy? dt by dy can be obtained by temperature profile T as a function of Y, and T as a function of Y can be obtained from the velocity profile. That is how there is a close connection between the heat transfer as well as fluid mechanics. All right. So that is how we can obtain. H is not a property of the fluid. It is experimentally determined complex parameter which depends on various factors like the fluid properties, the flow characteristic, whether it is laminar, turbulent, etc., the surface over which the fluid is flowing. So it depends on so many factors. That is why it is very, very difficult to calculate, to find out the value of convective heat transfer coefficient. In analyzing the convection, our objective is to get the correct value of convective heat transfer coefficient only. I hope this is clear. Let us move to the next one. Question number 2. In list 1, there are some surfaces and the mode. Plane wall having the conduction, mode of heat transfer, hollow cylinder with conduction, hollow sphere with conduction, and there is a convection over a surface. In list 2, there are thermal resistances similar to electric resistance. We have the thermal resistance. Yes, can you match the following? Plane wall. What is the thermal resistance? We can say Q is equal to delta T upon thermal resistance. This is how we can define Q. It is similar to Ohm's law. I is equal to delta V upon R. It is similar to Ohm's law. So this is called as thermal resistance, the way we define the electrical resistance. This is called as thermal resistance. What is the unit of thermal resistance? Anybody can give me the answer for unit of thermal resistance? Anirudh is saying 2143. 2143. Are you getting 2143? 2143. Pradeep is also saying 2143. Kumar is also saying 2143. What is the unit of thermal resistance? What will be the unit of thermal resistance? It is Kelvin per unit watt or degree Celsius per unit watt. The unit of thermal resistance. For a plane wall, it is L by Ka. For a plane wall, it is L by Ka, isn't it? L is the thickness of the wall. K is the thermal conductivity of the wall. A is the area normal to the direction of conduction. For a hollow cylinder, it is logarithmic. Ln R2 by R1 upon 2 pi KL. 2, 1. For a hollow cylinder, it is logarithmic, isn't it? For a hollow sphere, it is hyperbolic. R2 minus R1 upon 4 pi K R1 R2. And for the convection, Q convection is given by the Newton's law of cooling, H into A into delta T. If we compare this with delta T upon thermal resistance, so RTH for convection will be 1 upon H into surface area of the surface area in contact with the fluid. So C4 and D will be equal to, well done guys, well done, very nice, 1 upon HA. So 2, 1, 4, 3. Good evening Naniket, welcome. We are at question number 2. Let us move to question number 3. Question number 3 on your screen. Everyone, give me the answer. That is the question from the heat generation. Heat generation. Whenever there is a heat generation, the temperature profile is a parabolic. Whenever there is a heat generation, the temperature profile will be parabola. Whether the heat generation is in the plane wall, hollow cylinder, solid cylinder or solid sphere. In case of plane wall, the maximum temperature is at the center. Maximum temperature is at center. That is called as center line temperature, or we can call it as center line temperature. The maximum temperature will be at the center. So for a plane wall, T maximum is given by, whenever there is a heat generation in the plane wall, Ts plus Q dot L square by 8K. For Ts1 is equal to Ts2. Ts plus q dot L square by 8k. For a solid cylinder and for a plane wall, q is directly proportional to x. The rate of heat transfer q is directly proportional to x, that is linear, isn't it? For a solid cylinder, the maximum temperature or the center line temperature Ts plus q dot r square by 4k, and q is proportional to r square, that is parabola. And in case of solid sphere, T maximum is given by Ts plus q dot r square by 6k, and q is proportional to r cube, that is cubic. Linear, parabolic and cubic. It is about a solid cylinder. So it will be option C, isn't it? It will be option C. Are you getting it? Option C. I hope it is clear to everyone. It is option C. Nobody has given me the answer. Only Kumar had given the correct answer. Option C is the right answer for this one. Kumar, पिछले क्वेश्चन का जवाब दिया आपने या इस क्वेश्चन का? Let us move to question number 4. The next one. Question number 4 on your screen. Is this all clear to everyone? The heat flow through a composite cylinder. इसको लिख सकते हैं q dot r square by 6k is for solid sphere. This is for solid sphere. Q dot r square by 4k is for a cylinder. And q dot L square, if it would have been L square by 8k, then it would have been for a plane wall. Q dot L square by 8k. हाँ, यही तो सीखना है. If you are getting confused, you need to revise the formula again. This is simple. The heat flow through a composite cylinder. What is a composite cylinder? Composite cylinder means made up of number of materials. Which is made up of more number of material. That is called as composite cylinder. The equation for the heat flow, can we say Q is equal to delta T overall upon equivalent thermal resistance? That is equal to UA into delta T overall. We define the overall heat transfer coefficient also. So if you are able to write delta R equivalent for a cylinder, for a single cylinder, single hollow cylinder, it is ln of R2 by R1 upon 2 pi KL, isn't it? For number of cylinders, we will add all the resistances. So R equivalent will be equal to summation of J is equal to 1 to N ln of Rj plus 1 upon Rj ln of Rj plus 1 upon Rj upon 2 pi kj into L. This is R equivalent for a composite cylinder. This will be R equivalent. So delta T overall is equal to, if there are n layers, so delta T overall is equal to T1 minus Tn plus 1. So divide by equivalent thermal resistance, you will get the expression, isn't it? What is the answer for question number 4? Are you getting option A? A is the correct answer. Option A will be the right answer. Right? And this is for composite sphere. Option B is for composite sphere. Isn't it? And C is for composite wall. This is for composite wall. It is for a single cylinder. Option D is for a single cylinder. Yes, Anirudh, that is what I told you, na? Anirudh, that is what I told you. The only difference is D is for a single cylinder, A is for a composite cylinder. The question is about a composite cylinder. D is for a single cylinder and A is for a composite cylinder. That is the difference, right? So from D we can get A. That is what I have done. From option D I have obtained option A. The next one, question number 5. Formula for critical radius of insulation. What is the critical radius of insulation? It is the radius of insulation so that the heat transfer rate becomes maximum in a radial system. We insulate the radial system for the maximization of the heat transfer. The corresponding radius is known as critical radius of insulation. The question is about a sphere. So critical radius of insulation for a sphere is equal to twice of critical radius of insulation for a cylinder. And what is the critical radius of insulation for a cylinder? That is K for the insulating material upon H naught. That is the formula for a cylinder. The question is about a sphere. This question is about a sphere. So it will be 2K by H. H is the convective heat transfer coefficient of the outer fluid which is in contact with the insulating material, and K is the thermal conductivity of the insulating material. K is the thermal conductivity of the insulating material. K is thermal conductivity of insulating material. The unit will be watt per meter Kelvin. It is watt per meter Kelvin. And H is the convection heat transfer coefficient of outside fluid in contact with the insulating material. It will be watt per meter square Kelvin. So K by H, the unit will be, K is watt per meter Kelvin and H will be watt per meter square Kelvin. So the unit of K by H will be meter, isn't it? So meter will be the unit of radius. So H by 2K cannot be possible. H by 2K cannot be possible. And once we get the critical radius of insulation, we define the critical thickness also. Sometimes the question is asked about the critical thickness of insulation. This is the critical thickness. RC R minus R naught. That is the critical thickness of insulation. Right? So guys, there will be any scholarship test, national level scholarship test, which is conducted by BYJU'S on this coming Sunday, tomorrow. Tomorrow the test will be starting from 9 AM and it will end up to 9 PM. So you can appear for the test in any of the slot between 9 AM to 9 PM tomorrow. You just have to register yourself beforehand to appear for the test, and the link is already there in the description box. So please guys, do not forget to see the description box of this session to get all the important links, and do register yourself, and do not forget to like this session and share this session to all your friends. It is my humble request to all of you, please do like this session so it reaches to all the students who are sincerely preparing for GATE 2024. And based on your performance in the scholarship test, you will be able to get our paid courses. If you are interested to be part of our paid courses, you can talk to the students who had been part of our paid courses. You can take the feedback from them, and if you are interested, you can get our paid courses at a very discounted prices. Based on your performance, we will provide you the scholarship in our courses. All right, so let us move to the next question. Question number 6. We are having 20 questions in total. Question number 6 on your screen. From the fin theory, in list 1, long fin length is taken as infinite, and in list 2, the various formula related to the infinitely long fin. What is the nature of the temperature profile? nature of temperature profile is exponential. For infinitely long fin, nature of temperature profile is exponential. For short fin, the nature of temperature profile is hyperbolic, isn't it? For short fin, the nature of temperature profile is hyperbolic, but infinitely long fin, the nature of temperature profile is, so we can say theta upon theta s is equal to e to the power minus mx. What is m? M is equal to under root of hp by k into ac. That is called as fin constant. M is fin constant. The unit of m is meter inverse. So A2, yes, Q fin. What is the heat loss from the fin? The formula for heat loss is Kam theta s. Can you let me know? So A2 B4 Kam theta s, or we can say K into cross sectional area into m is under root of hp by kac into theta s. Theta s is equal to ts minus t infinity. So we can write it as under root of hpk into ac into theta s. So q fin is, can we say q fin is directly proportional to root h? Q fin is directly proportional to under root of k. It is directly proportional to root h, root k. Then C, efficiency of the fin, Q fin divided by Q maximum. And what is Q maximum? Q maximum is equal to the maximum heat loss from the fin when the entire fin is maintained at the base temperature. It is less than 1. So Q maximum is equal to H into PL into theta s. That is Q maximum. H into PL into theta s. That is Q maximum. So efficiency of the fin is 1 upon ml. C3. And what about D? Effectiveness of the fin is Q actual upon Q without fin. Q fin upon Q without fin. And what is Q without fin? What is Q without fin? That is H into AC into theta s, which can be less than, which can be greater than 1. Effectiveness can be less than 1, effectiveness can be greater than 1. So effectiveness is given by Km by H. D1. So 2431, 2431, Kumar. It will be 2431. Effectiveness is Km by H. Efficiency is, if somebody asks you to develop a relation, then do not forget to put m is equal to under root of hp by ka. 2431. सॉरी, हाँ ठीक तो है, 2431. अब कुमार फिर से आप 2413 क्यों लिख रहे हैं? इट विल बी 2431. Effectiveness is Km by H. Efficiency is 1 upon ml. There is a difference between efficiency is thermal performance parameter, whereas effectiveness is economic performance parameter, isn't it? कुमार क्या आप एग्री नहीं कर रहे? Effectiveness is the next is MSQ. The question is from the unsteady state conduction. What is Biot number? What is Biot number? Biot number is used in unsteady state conduction. Yes, it is MSQ. Question number 7. Biot number is Biot number. It is the ratio of conductive thermal resistance of the solid to the convective thermal resistance of the fluid. It is the ratio of conductive thermal resistance of the solid to the convective thermal resistance, or we can say it is the ratio of Q convection in the fluid to the Q conduction in the solid, isn't it? Because Q is inversely proportional to thermal resistance. So A cannot be true. It is not the ratio of conduction upon convection. A will not be. A और B कैसे सेम है? एक में Q लिखा हुआ है, एक में कंडक्शन थर्मल रेजिस्टेंस लिखा हुआ है. There is a difference. One is A is not correct. Q conduction upon Q convection is not true. It is R conduction in the solid upon R convection in the fluid. B is correct. And if we put the value, what is convective or Q convection is HA delta T upon Q conduction is KA delta T by L. Delta T getting cancelled out, AA getting cancelled out. So the Biot number is equal to HLC by K. It is HLC by K. C is also correct. Alpha tau by LC square is called as Fourier number. Alpha tau by LC square is called as Fourier number. So B and C. Yes, Aniket, well done. Kumar, A is not correct. A is not right. B and C are the correct answer. Alpha tau by LC square is Fourier number. Question number 8. Question number 8. Formula for temperature as a function of time for lump system analysis is the variation of temperature versus time in case of lump analysis is exponential. So theta is equal to T minus T infinity. Theta I is equal to Ti minus T infinity, where T is the temperature at temperature of the system at any instant tau, and Ti is the initial temperature of the system, and T infinity is the fluid free stream temperature. So theta, so the expression is actually theta upon theta I is equal to T minus T infinity upon Ti minus T infinity is equal to e to the power minus HA. A is the surface area upon rho CV into tau, or we can write it as e to the power minus B into tau. B is the thermal response. Or we can write e to the power minus tau upon tau star. Tau star is the thermal time constant. Or we can write e to the power minus Biot number into Fourier number. This is how we can get the expression for temperature versus time. Temperature as a function of time is exponential. So what is the correct answer? A is not correct. Anirudh, A थोड़ी हो गया. A में तो उल्टा लिखा हुआ है ना. And B is HA by rho CV. The unit is second inverse. The unit of B is second inverse. HA by rho CV. And tau star, that is time constant, is 1 by B. That is called as time constant. That is why the unit of time constant is second. That is rho CV by HA. That is the time constant. So B is the correct answer. Theta upon theta is equal to e to the power minus tau upon tau star. It is e to the power minus Biot number into Fourier number. Here also there is a problem. So option B is the correct answer, isn't it? B will be the right answer for this. For lump system analysis, the formula for temperature versus time is given by option B. Now we have entered into convection mode of heat transfer. Conduction is all over, along with the critical radius of insulation, critical insulation, fin theory, unsteady state conduction, composite system, heat generation, everything regarding the conduction is over. Now we have entered into the convection mode of heat transfer. What is the formula for bulk mean temperature at any section? In case of flow in a pipe, in case of flow in a pipe, there are two parameters defined. One is mean velocity at any section, another is the mean temperature at any section. There are two parameters defined, mean velocity and mean temperature. What will be the correct formula for mean temperature and how these formula are defined? Look, for mean velocity, the condition is mass flow rate, or that is integration of dm dot remains constant. Mass flow rate remains constant. That is the condition for mean velocity. The mean velocity is defined in such a way that local velocity will be replaced by a constant velocity such that the mass flow rate remains constant. So mass flow rate is rho into area, that is pi r square, into rho av is equal to integration of rho into dA, that is 2 pi r into dr, into u, which is a function of r. So if you simplify this, rho getting cancelled out, pi is also getting cancelled out, so we get is equal to 2 by r square integration 0 to r u into r dr. This is how we define the mean velocity, that is constant. Similarly, we define the mean temperature at any section, that says the heat flow rate remains constant. For the mean temperature, heat flow must remain constant. That is the condition. What is the heat flow rate? That is m dot into Cp into Tm is equal to integration of dm rho into, or let me write it as dm dot into Cp into T, which is a function of r. So Cp and Cp getting cancelled out. So what we'll write? What is m dot? That is rho into pi r square into um into Tm is equal to what is dm dot? That is equal to rho into 2 pi r into dr into u, which is a function of r, into T, which is a function of r. Density getting cancelled out, pi also getting cancelled out. So from here Tm is equal to 2 upon mean velocity into r square integration 0 to r, u, which is a function of r, T, another a function of r, into r dr. That is the formula for mean temperature, which will be constant at a particular section. This is the formula for mean temperature. So can you relate which is the exact expression? Option A. It is option A. It will be 2 upon Vm r square 0 to r integration 0 to r u into T into r dr. U into T into r dr. It will be 2. It will not be 1. C is not correct. Option A is correct, isn't it? Are you getting it? So let us move to the next one. Question number 10. Prandtl number is, we are halfway now. Let us solve the remaining questions quickly. Prandtl number is a fluid property. It is MSQ. Prandtl number is a fluid property which is the connecting link between velocity profile, which is the connecting link between velocity profile and temperature profile, or we can say which is the connecting link between fluid mechanics and heat transfer. That is the Prandtl number. What is Prandtl number? Prandtl number is the ratio of kinematic viscosity upon thermal diffusivity. The ratio of kinematic viscosity to the thermal diffusivity. B is correct. And what is kinematic viscosity? Mu by rho. Dynamic viscosity per unit density. Alpha is equal to K by rho C. Rho Cp. This rho getting cancelled out. So that is mu into Cp by K. Mu into Cp by K. B and D will be the correct answer, isn't it? Both B and D. And for laminar flow, or we can say for laminar boundary layer, Prandtl number will decide. If it is less than 1, then velocity boundary layer thickness is less than thermal boundary layer thickness. If Prandtl number is equal to 1, then delta V is equal to delta T. If the Prandtl number is greater than 1, then delta V is greater than delta T. So it is the Prandtl number we decide whether the velocity boundary layer thickness is more than the thermal boundary layer thickness or the reverse is true. Question number 10. Let us move to question number 11, but before that there is an important information. We will be coming up with another series. Yes, we will be discussing the PYQs, but not the recent PYQs. Recent PYQs had already been discussed on various platforms, but this time we will be discussing the questions, gate questions which had been asked in 90s. That the question paper used to be a little bit on the difficult side earlier in 90s. So we will discuss the hand-picked questions from the gate 90s papers. So the series will be going to be started from 6th of November. All right. So do not forget to join this series. The next one, which of the following options are correct? Again, MSQ. The next one, which one of the following options are correct? For laminar flow over a flat plate, when the Reynolds number is less than 5 into 10 to the power 5. For laminar flow over a flat plate, delta x is given by 5x upon under root of Rex, where what is the Reynolds number? That is rho into u infinity x by mu. So delta x is directly proportional to root x. It is not proportional to x. A is not correct. For laminar flow over a flat plate, delta x by delta t is given by Prandtl number to the power 1 by 3. That is correct. B is correct. A is not correct. It is not proportional to x. It will be proportional to root x. And in case of turbulent flow over a flat plate, when the Reynolds number is greater than 5 into 10 to the power 5, in case of turbulent flow, delta x is given by 0.376x upon Rex to the power 1 by 5. Rex upon 1 by 5. So delta x is proportional to x to the power 4 by 5. That is true. C is also correct. And Nusselt number is constant for laminar flow in a pipe. Laminar flow in a pipe when the Reynolds number is less than 2000. In case of Reynolds number less than 2000, Nusselt number is constant. And the value of constant is 4.36 for constant heat flux condition. And the value of this Nusselt number to be constant is 3.66 for the surface temperature of the pipe to be constant. D is also correct. So B, C, D, sorry. Just hold on. Are you able to see the screen? So B, C, D are the correct answer for this one. B, C and D. It is not ABC, it is B, C, D. I hope this is clear. Let us move to question number 12. Match the following. For Nusselt number, laminar flow over a flat plate, that is external flow. For laminar flow over a flat plate, Nusselt number is given by, is proportional to Reynolds number to the power 1 by 2 into Prandtl number to the power 1 by 3. And what is Nusselt number? That is h into x by kf. So for laminar flow over a flat plate, Nusselt number is proportional to Reynolds number to the power 1 by 2 and Prandtl number to the power 1 by 3. A2, turbulent flow over a flat plate, Nusselt number is given by Reynolds number to the power 4 by 5 into Prandtl number to the power 1 by 3. So here we can say h is proportional to x to the power minus 1 by 2, isn't it? H is proportional to x to the power minus 1 by 2 because Nusselt number is having x, and here we can say h is proportional to x to the power minus 1 by 5. That is Hx, local convective heat transfer coefficient. Now if we talk about the turbulent flow, so B is related with 1, 4 by 5 is, so A to B1, laminar flow in a pipe, Nusselt number is constant. Nusselt number, that is H into D by Kf is equal to constant. So here H is proportional to D to the power minus 1. Nusselt number is constant, C4, and if it is turbulent flow, then Nusselt number is proportional to Reynolds number to the power 4 by 5, sorry, it will be proportional to 4 by 5 into Prandtl number to the power 0.4. So here we can say H is proportional to D to the power minus 1 by 5. Are you getting it? So 2143 A2 B1 C4 D3. Yes, Rudra, well done, good. Are you able to understand this? You need to memorize these formula. I hope you guys are liking this session where we are discussing the formula in a different manner. It is only the formula we are discussing here. The next question on your screen. So do like the session, guys, and do not forget to subscribe our BYJU'S channel and do share this session link also to all your friends and colleagues. For natural or free convection, it is the buoyant force which causes the fluid motion. In case of natural convection, it is the buoyant force which causes the fluid motion, whereas in case of forced convection, it is the inertia force which causes the fluid motion. So in case of natural convection, when the flow motion is laminar, when do we have laminar motion? Laminar motion is when the Grashof number is less than 10 to the power 9. It is the Grashof number which is used in case of natural convection. So Nusselt number is proportional to Grashof number into Prandtl number to the power 1 by 4. If it is turbulent motion, when the Grashof number, it is not Reynolds number now, it is greater than 10 to the power 9. Nusselt number is proportional to Grashof number into Prandtl number to the power 1 by 3. So this is the only difference, and the product of Grashof number and Prandtl number is called as Rayleigh number. What is Rayleigh number? The product of Grashof number and Prandtl number, that is called as Rayleigh number. So Nusselt number for laminar motion, it is 1 by 3, that is incorrect. It is 1 by 4. For turbulent motion, it is 1 by 4, that is also incorrect. For turbulent, it is 1 by 3, and for laminar, it will be 1 by 4. Only C is the correct answer. C will be the right answer. Option C will be the correct answer. C. Yes, Rudra, well done, good. Rahul, keep it up, guys. Please do participate, everyone. And what exactly is the Grashof number? Who remembers the formula for the Grashof number? That is called as local Grashof number. Local Grashof number. What is the Grashof number? If you talk about the Reynolds number, that is the ratio of inertia force by viscous force. But inertia force will be replaced by buoyant force. The Grashof number is the ratio of buoyant force by viscous force. And mathematical expression is given by local Grashof number rho square g beta delta t x cube by mu square. And mu by rho is called as kinematic viscosity. So g beta delta t x cube by kinematic viscosity square, where beta is called as coefficient of thermal expansion, or we can call it as volumetric expansivity. It is a thermodynamic property. Coefficient of thermal expansion. And for an ideal gas, it is 1 upon film temperature. The unit is Kelvin inverse. And what is the film temperature? Film temperature is equal to Ts plus T infinity by 2. It is the mean temperature of surface and the fluid. So beta is 1 upon film temperature. So what is the correct expression? G beta delta T x cube by, it will not be mu square, it will be kinematic viscosity square. C. Lag हो रहा है? C will be the answer, right? And there is lag नहीं हो रहा ना, अंशुमन कह रहे नहीं. Yes, थोड़ा बहुत 2-4 सेकंड का लैग हो सकता है. Up to 7-8 seconds lag is still okay, but if it is lagging more than 1 minute or more than 30 seconds, then there is a problem. So there is an important interactive workshop on 8th of November at 7:30 p.m. which is taken by Joshit sir. He will be guiding you to develop the right strategy if you want to secure all India rank under 100 in your GATE 2025 exam. You just have to register yourself and the registration link is there in the description box. All right, Rajput. So let us move to the next one quickly. Few more questions. Now we have entered into heat exchanger. Convection is all completed now. Now we have entered into the heat exchanger. LMTD for a counterflow heat exchanger. What is LMTD? That is called as logarithmic mean temperature difference. Why do we define LMTD? Because there is a variable temperature difference between hot fluid and cold fluid. So the variable temperature, this is TH1, entry temperature of the hot fluid. This is TH2, exit temperature of the hot fluid. This is TC1, entry temperature. This is TC2. Because there is a variable temperature difference between hot fluid and cold fluid, what we do is we define the constant temperature difference between the hot fluid and cold fluid. That is called as delta Tm. That is called as LMTD. So how to calculate delta Tm? Generally, what we do, we find out delta T1 minus delta T2. What is LMTD? Delta Tm is equal to, so delta Tm is equal to delta T1 minus delta T2 upon natural log of delta T1 by delta T2. It is parallel flow actually. The question is about the counterflow. So what you need to do is you just use the same formula but after drawing the temperature profile. For a counterflow heat exchanger, if we draw the temperature profile will be looking like this. This is the hot fluid TH1. This is TH2, outlet temperature. The cold fluid is entering from here, TC1, TC2. This is delta T1, this is delta T2. So if we write LMTD, delta Tm for a counterflow, so delta T1 is TH1 minus TC2 minus delta T2 is TH2 minus TC1 upon natural log of delta T1, that is TH1 minus TC2 upon TH2 minus TC1. So that is the formula for LMTD for a counterflow heat exchanger. Acha, Rudra, data insufficient, data pack insufficient. What is the answer to this one? 5 क्वेश्चन और है रुद्र, अगर आप रुक सकते हो तो. Only 5 questions away. So what will be the answer? Is it option B? Option B is the right answer. Yes, well done. Option B is the correct answer. Now match the following with the effectiveness. What is the effectiveness of the heat exchanger? That is Q upon Q maximum, Q actual upon Q maximum, and Q actual can be calculated by either CH into delta TH or CC into delta TC or U into A into delta TM. And what is Q maximum? Q maximum is C minimum into TH1 minus TC1. What is C minimum? C minimum is minimum among CH and CC. C minimum, that is the heat capacity rate. C is called as heat capacity rate. Heat capacity rate, that is the ratio of mass flow rate into specific heat. The ratio of mass flow rate into specific heat. So for parallel flow heat exchanger, and C is called as C minimum by C maximum, that is called as heat capacity ratio or capacity ratio. It is called as ratio, and N is called as NTU, number of transfer units, UA by C minimum, which represents the size of the heat exchanger. Now for a parallel flow heat exchanger, which one? For a parallel flow heat exchanger, for a parallel flow heat exchanger, it will be 2. For counter flow heat exchanger, it will be 3. If C is equal to 1, when C is equal to 1, when CH is equal to CC, when CH is equal to CC, if you put C is equal to 1, then you will get denominator as 2, so it will be 4. And when C is equal to 1 for counter flow heat exchanger, it will become a special case. It will become a special case. So we will use L'Hospital rule. We will use L'Hospital rule. We will get NTU upon NTU plus 1. So 2, 3, 4, 5. Are you getting 2, 3, 4, 5? 2, 3, 4, 5. 1 minus e to the power minus 1 is for C is equal to 0. This will be for C is equal to 0. It means there is a phase change. For a fluid undergoing a phase change, then it will be 1 minus e to the power minus 1. 2, 3, 4, 5 will be the correct answer for question number 16. Let us move to the question number 17. Formula for shape factor. Let me know how many of you remember. Shape factor is given by Q1 to 2 upon Q1. That is shape factor 1 to 2. It is less than, it lies between 0 and 1. The value, the shape factor lies between 0 and 1. That is called as radiation shape factor. Now Q1 is equal to J1 into A1, or we can write it as pi into intensity into A1, that is Q1. Q1 is equal to pi I and A1. And what is Q1 to 2? So it will be calculated from intensity of radiation. What is intensity? That is del Q1 to 2 upon dA1 cos theta 1 into dA2 cos theta 2 upon R square. That is called as intensity. dA1 cos theta 1 is the projected area of the radiating surface. dA2 cos theta 2 by R square is the solid angle. So from here we can write, or we can write Q1 to 2 is equal to In. It will be integration A1 then A2 then dA1 cos theta 1 dA2 cos theta 2 upon R square. So if we write F1 to 2, that is Q1 to 2 upon Q1. So it will be In double integration dA1 cos theta 1 into dA2 cos theta 2 upon R square, divide by pi into In into A1. So this In getting cancel out. So F1 to 2 is equal to 1 upon A1 double integration then dA1 dA2 cos theta 1 cos theta 2 upon pi R square. Similarly, we can write पता नहीं कहाँ चला गया, there is some problem going on. So similarly we can write F2 to 1 is equal to 1 upon A2 double integration dA1 dA2 cos theta 1 cos theta 2 upon pi R square. So F122 is not equal to F221, but A1 into F122 is equal to A to F221. That is called as reciprocity theorem. What do we call this? This is called as reciprocity theorem. So what is the correct answer? What will be the answer for this one? F122 1 upon A1. Are you getting option C? Yes, C will be the right answer. C will be the answer for this one. Do you understand question number 17, option C? I hope it is clear. Question number 18. The various radiation laws and their expressions. The various radiation laws and their expressions. Match the column. Question number 18. We are having couple of more questions. That's it. I will share the PDF of this session to my Telegram channel. Stephen Boltzmann law, very simple. Stephen Boltzmann law. For emissive power of the black body, A4 na. It will be A4. Wien displacement law, lambda maximum into temperature is constant, that is 2898 micrometer Kelvin. B3, A4 B3. Kirchhoff's law, emissivity is equal to absorptivity for temperature to be constant when the body is in thermal equilibrium with its surrounding, with its environment. So C1, A3, B4, C1, and Lambert constant law is regarding the intensity. Intensity in any direction is given by In cos theta. So D2. 3412. 3, A3, sorry, 43. 4312. 4312. Well done. Question number 18. Question number 19. We are about to complete formula for radiation surface resistance. There are two type of resistances in radiation. One is called as space resistance, another is surface resistance. This is called as space resistance. The space between the two surfaces provide this resistance. The unit will be meter to the power minus 2. The unit of resistance will be meter to the power minus 2. Yes, the surface resistance is given by option C. When the surface resistance is equal to 0, the body is called as black body. So when do we have the surface resistance to be 0? Either epsilon is equal to 1 or area is infinite. In both the cases, the body will be called as black body. When the surface resistance is not 0, then the body is called as non-black body. It is the surface resistance which decide whether the body is a black body or a non-black body. So the correct answer is option C. Let us move to the question number 20. Second last question for the day. For n radiation shield with equal emissivity, epsilon 1 is equal to epsilon 2 is equal to epsilon. All the surfaces are having equal emissivity. Then what is the ratio of heat loss, heat transfer rate, radiation heat transfer rate with n shield to the no shield? 1 upon n plus 1. N shield upon no shield will be 1 upon n plus 1. C will be the answer. Well done. Good guys, good. Keep it up. You have to memorize this formula. When the emissivities are equal, then we get this expression. N is the number of shields, where n is the number of radiation shield. And then the radiation heat exchange. In list 1, there are some surfaces. We need to find out Q122 net. The formula for Q122 net is given by, yes, the last question. The formula for Q122 net is given by sigma A1 T1 to the power 4 minus T2 to the power 4 1 minus epsilon 1 upon epsilon 1 plus 1 upon F122 plus A1 by A2 into 1 minus epsilon 2 upon epsilon 2. That is the general expression. This is the general expression. Right? Now, a small object in a large cavity. So we can say A1 by A2 is 0. A1 by A2 will become 0. when A1 by A2 will become 0, and because it is a large cavity, F122 is equal to 1. So put A1 by A2 is equal to 0 and F122 is equal to 1. If we put F122 is equal to 1 and A1 by A2 is 0, then we are left with sigma into A into epsilon into T1 to the power 4 minus T2 to the power 4. Infinitely large parallel plates. So here A1 is equal to A2 and F122 is equal to 1. If A1 is equal to A2 and F122 is equal to 1, that is called as infinitely large parallel plates. What will be our expression? Isn't it sigma into A1 into T1 to the power 4 1 by epsilon 1 plus 1 by epsilon 2 minus 1. So B1 infinitely long concentric cylinders. So A1 by A2 is equal to R1 by R2 because it is the cylinder. A1 is 2 pi R1L, A2 is 2 pi R2L. F122 is equal to 1. Put the values here. Then C4. And if it is concentric spheres, then A1 by A2 is equal to R1 by R2 square. And F122 is equal to 1 because they are concentric spheres. So D3. 2143. Isn't it 2143? 2143. Are you getting it? So that completes our session. That is all about this session. I hope you enjoyed the session and you understand the concept. So we are running, not this one, we are running crash course for GATE 2024 aspirants and the long-term batches for GATE 2025 and 2026 aspirants. And there are some beautiful series which are running on BYJU'S YouTube platform. If you have not subscribed our BYJU'S YouTube channel, please do subscribe so that you will be getting the important notification. This is the link to join me on the Telegram as well. So that is all from my side. Have a great Sunday. Enjoy your day. Enjoy your evening with your friends and family. Take care of yourself. Thank you very much for being being actively participating in this session. I thoroughly enjoyed it. I hope you guys have liked this session. See you in the next session. Till then, enjoy, take care, have a good night, Shubh Ratri, Sabba Khair, and Jai Hind.